now we are going to see the selection of flat bed drive. Okay, so for selection of the flat bed drive, we are going to require some data. So in the problem they will mention some data. So the information required for selection of a flat bed drive will be the power to be transmitted. So in the problem they will mention that how much power you need to transmit with the help of belt drive. Then you need the input and output speeds of the smaller pulley and the bigger pulley. Okay, so generally the input speed will be given to the smaller pulley. Okay, and the output speed will be generally less than the input speed. Okay, then you need the center distance between the two pulleys. Okay, and you need the type of load you are going to attach to that belt drive. Okay, so what type of load you are attaching? Suppose you are attaching a compressor or you are attaching the pump. Okay, so and what is the capacity of that compressor or pump? So you need the type of load. Okay, so this much data is required, and you need to find out the maximum power going to be transmitted by your belt. Okay, considering that load. Okay, so if you are considering the load, then you have to multiply by one factor called as the load correction factor, which is denoted by FA. Okay, so we'll see how to find out FA from the given table. Now let me start the procedure. Now you have to follow the same procedure when you are going to select the belt drive. First is the step number 1. You have to assume certain belt velocity. Okay, for the company which is going to manufacture this flat belt drive. So here for our information, the catalogs of Dunlop companies are given. Catalog means they will provide the information, the tables, right? So Dunlop companies giving the range of the speed of the belt available with them. Okay, so that range is near about 17.8 to 22.9 meter per second. So that is the linear velocity of the belt. So we have to select the value in between that. Okay, so after selecting the value of the required speed, okay, after selecting the value, you substitute the values and you find out the dimensions of the smaller pulley, that is the diameter of the smaller pulley. Okay, so after finding the diameter with the help of velocity ratio, you find out the bigger diameter of the bigger pulley. Okay, and these two diameters you have to select, okay, from the given standard table. Okay, so the standard table will be available to you like this. Now this is the table from which you have to select the diameters of the pulleys. So you have calculated some diameter. Let me say it is near about 238 mm. Okay, that is the diameter of smaller pulley. So if 238 is there, then obviously you have to go for the maximum value of the 238. So here you can select 250 as the diameter of smaller pulley, and as velocity ratio is 2, so you have to go for the dia of the bigger pulley as 500. So now we are fixing the diameters of the pulleys as 250 mm and 500 mm from this given table. Understood? So this is how we can select the diameters. So this is the first step. You have to select the diameters of the pulleys. I hope you understood this one. Okay. Now after selecting the diameters, you have to correct the velocity of the belt which you already assumed. So you assume certain values of the velocity. Now after selecting, you find out once again the velocity of the belt with the help of the same formula, that velocity of belt V equals to pi dn by 60. So now you will get the corrected velocity of the belt. Let me say it is 18.85 meter per second. Understood? So first step of the flat belt drive is to select the diameters. Understood? And correct the belt velocity. Okay. After that, you have to select the value of the load correction factor, FA. Okay. Now this FA can be selected depending upon the type of load available to you, or you are going to attach to the given belt drive. So here is the table from which you can select the value of FA. Okay. Now for us, the compressor is given in the problem. So for the compressor, okay, and intermediate working, the value of FA. So here is the column of FA. So FA will be 1.3, right? Or if centrifugal pump is given or fans like that is given, then you can select FA as 1.2. But for our case, compressor is going to attach, so the load factor will be 1.3. Okay. So after selecting FA as 1.3, now you have to find out the maximum power going to be transmitted with the help of this formula. So you multiply the FA to the actual kilowatt given in the problem. Now for us, the actual kilowatt is 25. Okay. So you multiply 25 kilowatt with the selected FA as 1.3. So the maximum power will be 32.5 kilowatt for the given problem. Okay. So this is the step number 2. You have to find out maximum power, that is kilowatt maximum. Okay. So power is denoted by kilowatt. Remember. Step number 3. Now you have to calculate the angle of wrap or arc of contact. Okay. So that can be determined, okay, with the help of your usual formula, and you have to calculate the angle of contact for the smaller pulley. Okay. So let me say angle of contact is alpha and S stands for smaller pulley. So alpha S will be equals to 180 minus, because angle of wrap for smaller pulley is always less than 180. So it will be 180 minus 2 into sine inverse of D minus D divided by 2C, where this D, capital D, is diameter of bigger pulley, small d is the diameter of smaller pulley, and C is the center distance. Suppose this alpha S is near about 175. Okay. Now you have to select the correction factor for this given calculated arc of contact. Suppose for us the arc of contact is 175. So we have calculated alpha S as 175, and we have to find out the correction factor for this arc of contact FD, okay, for 175. So as 175 is not given, so it is the middle of this 170 and 180. So middle of 1.04 and 1.00 will be 1.02. So selecting FD as a 1.02. So after calculation of FD, now multiply the maximum kilowatt, okay, with this value of FD. Means the fourth step is that you have to find out the kilowatt corrected. Okay, means corrected power you have to find out for the given arc of contact. Okay, so we are multiplying the factor which is going to consider the arc of contact, that is FD. Okay, so we will get kilowatt corrected. Okay, now each company is having their own rating. Okay, so for Dunlop company 2 ratings are available: high speed belt rating and the Ford belt rating. So 2 ratings are there: high speed and Ford speed. So for each rating there is certain multiplication factors are there. So this will be given to you, or you have to remember. So generally this factor, this will be given in the problem, 0.0118 into V, where this small v is the corrected velocity of the belt, means that 18.85, which we have already corrected, okay, in the step number 1. So that you have to multiply here with this factor, and you have to divide with the mean speed as 5.08 meter per second. So this 5.08 meter per second is the mean speed of the belt. Understood? So like that, depending upon the rating, now you find out the correct rating for you. Okay. If it is mentioned that you select high speed, you have to multiply by 0.0118. If it is mentioned in the question that select the Ford belt, then you have to multiply by 0.0147 to your corrected velocity. Understood? Now after selecting the rating of the belt, okay, now the next step is that you have to select the width and the number of plies for the belt. So with the help of this formula, width into number of plies, okay, will be equals to kilowatt corrected divided by corrected kilowatt ratings. Okay. Now for us, we already calculated this kilowatt corrected by multiplying by FD. Okay. So corrected rating we already selected. Okay. Now for given number of plies from the table, available table, suppose we have selected 4 number of plies. Okay. So you divide the right side, okay, with the number of plies, so that you will get the width of the belt. You will get the width of the belt for the selected number of plies. Okay. So for the selected, suppose 4 number of plies, now we have 189 mm as a width, but in the table 189 mm is not available, 189 is not available. So we cannot go for 4 number of plies. So then select the 5 number of plies. So for 5 number of plies, you divide this whole right side by 5, you will get certain width. Suppose this width is 151 mm now. So for 5 number of plies, 151 means now the available mm is 152. So now you can select the width of the belt as 152. So our belt, flat belt will be of width 152 mm and for 5 number of plies. Okay. So this is the conclusion for step number 6, and last step is that you have to find out the length of the belt with your usual formula. Either it is for open belt or for cross belt. If it is a cross belt, then instead of this D minus D, it will be D plus D. The whole formula will be same. Instead of minus, it will be plus. Okay. So understood? So like that, if I revise in the step number 1, okay, we are calculating the diameters, right? In the step number 1, we are calculating the diameters and the corrected belt velocity. In the step number 2, we are finding the kilowatt maximum, okay, by selecting FA as a load correction factor from the table. Then we are calculating alpha S. So for that alpha S angle of wrap, we are determining FD from table. Then we are selecting, we are calculating the corrected kilowatt. Then after that, step number 5, we are selecting a certain rating of the belt. After finding the rating of the belt, then you have to, for number of plies, you have to find out the width, and you have to see from the table that width is available for given number of plies or not. Understood? And the last step is that you have to find out the length of the belt. Understood? So this is how we can select the flat belt drive.